Picture starting your usual workday, walking onto a factory floor, a drilling platform, or some other industrial site, with no idea that the countdown to the end of your life has already started. We rely on engineering systems, clear communication, and established workplace procedures to ensure our safety. But whenever those systems fail, when communication breaks down, or when corporate carelessness leads to cutting corners, what begins as a normal shift can turn into an inescapable death trap. Today, we look at 3 of the most frightening industrial accidents in human history, incidents in which sudden mechanical failure and catastrophic mistakes left the workers with no possibility of survival. These cases serve as a sobering reminder of how quickly the environments we create can turn against us. Our first case brings us to November 1983, in the cold waters of the North Sea, on the semi-submersible drilling platform called the Byford Dolphin. On this platform, a team of specialized divers worked as saturation divers. This dangerous job involves living for weeks inside a pressurized steel chamber that matches the pressure of the deep ocean floor in order to keep the blood gases stable. In order to carry out their work, the divers moved from their living chamber into a diving bell that was lowered into the sea. On the morning of November 5th, 2 British divers, Edwin Coward and Roy Lucas, were resting in the pressurized living area. At the same time, 2 Norwegian divers, Bjorn Bergensen and Truls Hellevik, were coming up from a deep sea shift and traveling to the surface inside the diving bell. The bell was successfully hauled onto the deck of the Byford Dolphin and secured to the trunkway, which connected it into the living chamber. The pressure inside both the bell and the living quarters was equalized to an incredible 9 atmospheres. In order to carry out the safe transfer of the divers, a strict, multi-step procedure had to be followed. First, the divers in the trunkway had to close the internal hatch that linked the bell to the living quarters. Then, the surface crew had to slowly reduce the pressure in the small trunkway space. Only after that space had reached normal surface pressure could the heavy metal clamp holding the diving bell to the rig be safely released. Outside the capsule, 2 experienced dive tenders, William Crammond and Saunders, were in charge of the heavy equipment. Suddenly, a fatal miscommunication took place. Before the divers in the tunnel had fully secured the internal pressure hatch and before the trunkway had been safely depressurized, William Crammond released a large external locking clamp. The results were immediate and disastrous. With the internal hatch still slightly open, the 9 atmospheres of pressure inside the chamber burst outwards into the normal surface pressure on the deck. This explosive decompression ripped the diving bell free from its mounting, instantly killing Crammond and seriously injuring Saunders. Inside the chamber, the sudden drop in pressure caused the gases dissolved in the diver's blood to boil instantly. For Coward, Lucas, and Bergensen, death came immediately as their circulatory systems failed. Hellevik, who was standing at the open hatch, was blown through a tiny gap, just 2 inches wide, and his body was instantly destroyed. The physical reality of this scene was horrifying. When the air violently escaped, it acted like a high-powered vacuum. Investigators later found that the internal organs of the men inside had literally ruptured from the inside out due to the sudden expansion of gas. The force was so immense that parts of the rig's structural metal were warped. The remaining crew on deck could only look on in absolute shock at the absolute devastation left behind in a fraction of a second. The Byford Dolphin disaster is still a haunting example of the complete lack of tolerance for error under pressure. From the North Sea, we go to the sleeping city of Bhopal in India in December 1984. The location is the Union Carbide pesticide plant, an industrial complex that manufactured chemical products. One of the key ingredients was methyl isocyanate, a gas that is extremely volatile and poisonous. Because of its extreme toxicity, the gas was stored in huge, double-walled underground tanks and kept at near freezing temperatures to prevent it from turning into a highly pressurized vapor. By the end of 1984, the plant was suffering from serious financial difficulties due to a fall in sales. In order to reduce operating costs, corporate management introduced severe budget cuts. They cut the number of safety maintenance staff in half, ignored failing temperature gauges, and turned off the refrigeration units that were cooling the tanks in order to save electricity. Most importantly, the plant's 3 main safety systems, a gas scrubber, a flare tower, and a water curtain, were either damaged or completely switched off. On the night of December 2nd, a routine maintenance shift was scheduled to clear a series of blocked pipes connected to storage tank 610, which contained 42 tons of pure methyl isocyanate. Because of poor training and the absence of safety valves, the high-pressure water used to clean the pipes leaked past a broken seal and entered the chemical tank. When water and methyl isocyanate come into contact, they produce a violently exothermic reaction. Inside tank 610, the temperature rose rapidly, causing the liquid chemical to boil and turn into an unstoppable stream of pressurized gas. The concrete floor above the underground tank began to crack and hiss as the pressure forced its way past the emergency release valves. Since all three safety systems had been switched off or were broken, the toxic vapor shot straight out of the exhaust stacks into the night air. The leaking chemical was a dense, heavy cloud that stuck closely to the ground. Carried by a light breeze, a white blanket of death moved slowly across the nearby shanty towns where thousands were sleeping. The gas attacked the eyes and lungs right away, waking people up with the feeling that boiling acid was filling their throats. Panic spread through the streets as thousands tried to escape, only to collapse as fluid filled their lungs. Over 3,800 people died in the first 72 hours, and the total number of deaths eventually reached more than 16,000, making the Bhopal disaster the worst industrial accident in history. The aftermath of this leak left an entire city in ruins. Survivors were left permanently blinded, and thousands suffered from severe, lifelong respiratory diseases that made regular work impossible. The local hospitals were completely overwhelmed within hours, running out of basic medical supplies and oxygen tanks as victims lined the hallways. For generations, the soil and groundwater surrounding the abandoned plant remained highly contaminated, leading to a massive spike in birth defects and chronic illnesses among local children. It stands as an ongoing tragedy that continues to ruin families decades after the initial cloud cleared away. Our final tragedy takes us to July 1988, off the coast of Scotland in the rough waters of the North Sea. Rising above the waves was the Piper Alpha, a massive oil and gas production platform owned by Occidental Petroleum. The Piper Alpha was a multi-billion-dollar engineering achievement responsible for producing nearly 10% of the United Kingdom's total North Sea output. Over 200 men lived and worked on the platform full-time, and during long shifts, surrounded by high-pressure hydrocarbons. On the afternoon of July 6th, a routine maintenance job was scheduled for condensate pump A, one of the main pumps used to move liquefied petroleum gas. A maintenance team removed the pump's primary safety relief valve to inspect it. However, since the shift was ending and the replacement parts had not arrived, the workers were unable to complete the job. They therefore covered the open pipe with a temporary metal blind flange disc, tightened the bolts by hand, and recorded the paperwork that pump A was non-operational and must not be switched on under any circumstances. When the night shift took over, a serious breakdown in communication occurred. The day supervisor did not orally inform the night manager about the missing safety valve, and the paperwork log was accidentally placed into a separate file stack that was not read. At 9:45 p.m., the rig's main operating pump, condensate pump B, suddenly suffered a mechanical failure and shut off, stopping the flow of gas. The night crew rushed to restore power in order to avoid a costly system-wide shutdown. Finding no obvious problems on the main terminal screen, the supervisor decided to switch on the backup unit, condensate pump A. As soon as the huge pump started up, thousands of pounds of high-pressure liquid gas rushed into the open pipe. The temporary metal disc, held only by a hand-tightened bolt, instantly gave way under the tremendous force. A large amount of flammable gas sprayed across the pump room and found an ignition source, triggering a colossal initial explosion that shattered the control room and blew out the primary safety walls. The design of the Piper Alpha proved to be its ultimate undoing. The firewall partitions had been built to withstand oil fires, not gas explosions. The blast severed the main oil lines, causing a massive pool of burning crude to melt the structure from the inside out. Worse, the emergency automatic water deluge system, which was supposed to flood the decks with seawater to extinguish fires, had been manually turned off by the diving supervisor earlier that day to protect underwater divers from being sucked into the intake pipes. As a chain reaction of explosions tore through the platform, a towering wall of thick, black smoke engulfed the crew quarters, where the majority of the workers had gathered according to their emergency evacuation plan. But the emergency helicopters could not land through the smoke, and the lifeboats were blocked by sheets of blazing fire. Out of the 226 men on board that evening, 167 lost their lives as the massive steel legs of the platform softened under the 2,000-degree heat, causing the entire multi-story rig to collapse and sink to the bottom of the North Sea. The scale of the loss on the Piper Alpha reshaped the entire offshore energy industry. The heat from the fire was so intense that rescue vessels over 100 yards away reported that their own paint was blistering and peeling off. Many of the men who survived were forced to jump over 170 feet directly into the freezing, oil-slick sea below, sustaining horrific injuries on impact. The families of the victims had to wait days for any word of survival, and the psychological trauma left the few survivors completely unable to ever return to offshore work. These three industrial catastrophes expose a chilling reality. The tools, machines, and facilities we engineer require absolute, unyielding precision to control. When the systems designed to keep us safe are neglected, the workplace ceases to be a livelihood. It becomes an unforgiving trap where the margin for error drops below zero.